In this presentation, we will be seeing about clot retraction and fibrinolysis. Clot retraction and fibrinolytic system can be asked as write briefly questions for 4 marks. One more question that can be asked is explain why blood does not normally clot inside the body. Coming to the first question, clot retraction. So first about what is blood clot? Blood clot is composed of a meshwork of fibrin thread running in all directions and has entrapped platelets, red cells and plasma. So within a few minutes after the clot is formed, it begins to contract and squeeze out serum. This process is called as clot retraction. And clot retraction is the function of platelets. Now what is serum? It is plasma minus the clotting factors. About the mechanism of clot retraction, platelets form filopodia that extend along the fibrin threads. The fibrin strands tug with the filopodia. So when the platelets shrink, there is contraction of the filopodia. This causes internalization of fibrin within the contracted platelet. Now you can represent this as a flowchart also. The next point is thrombin and calcium accelerate clot retraction and glycoprotein, that is GP2B3A receptors, which are on the surface of the platelets, facilitate clot retraction. Then write about the functions of clot retraction. So a retracted clot strongly seals the injured vessel. It facilitates wound healing. Clot retraction also prevents thrombolysis. Next, about the prolongation of clot retraction time. So normally, clot retraction begins in 30 seconds after clot formation. 50% of the retraction occurs at the end of 1 hour and it is completed in 18 to 24 hours. Clot retraction time is said to be prolonged when retraction is less than 50% at the end of 1 hour. Prolonged clot retraction is seen in the following conditions. One is Glanzmann's thrombocythemia, which is a deficiency of glycoprotein 2B3A. And in the case of thrombocytopenia, which is reduced platelet number. Next question is about fibrinolysis. So fibrinolysis is a process that brings about lysis of the clot or dissolution of fibrin. The important component for this process is plasmin or fibrinolysin. It is an enzyme that causes lysis of the clot, but it is present in an inactive form called as plasminogen. And this process of fibrinolysis occurs in 3 steps. First is activation of protein C. Then there is activation of plasmin, and then there is actual fibrinolysis. Then write about the mechanism of fibrinolysis. Write about the 3 major steps. So activation of protein C is brought about by thrombin and thrombomodulin. So this activated protein C along with cofactor protein S inactivates activated factor A and activated factor 8. Also, protein C activates plasminogen activator. So this goes and activates plasmin. Then fibrin is degraded to fibrin degradation products, FDP, by this plasmin. Now this FDP levels, like D-dimer, indicates the extent and rate of fibrinolysis. Then write about the physiological role of fibrinolysis system. First, it helps in clearing minute clots of tiny vessels. It promotes the normal healing process. It brings about liquefaction of the menstrual clot. And it has a role in inflammatory response. This is by the following mechanism. Plasmin can form plasma kinins like bradykinin, and this contributes to the inflammatory response to injury. Then about plasminogen activators. There are two major plasminogen activators, tissue plasminogen activator TPA and urokinase. It is also called as urokinase plasminogen activator. So this TPA is synthesized by endothelial cells, and fibrin facilitates TPA activity by increasing affinity of TPA for plasminogen. Next, coming to urokinase, it is formed by endothelial cells, macrophages and renal epithelial cells, and it is more effective activator of plasminogen than TPA. Now, streptokinase is a variant of urokinase. Now these two are, that is TPA and urokinase, are used in the treatment of acute myocardial infarction for the intracoronary lysis of the clot. Now coming to the next question, why normally circulating blood does not clot? The first point is velocity of circulation. So blood is pumped into the vessels and it is circulated at a constant velocity. When there is a decrease in circulation velocity, there is intravascular clotting. Now at this point, you must also remember that in polycythemia, there is a decrease in velocity of circulation, hence there is increased chance of platelet plug formation and increased chance of clotting. Next, the surface effects of the endothelium also contributes to the blood not clotting within the body. So there is endothelial lining is smooth. So the smoothness of the endothelial lining inhibits platelet adhesion. And an intact endothelium acts as a barrier between the thrombogenic subendothelial collagenous tissue and the blood. So when there is surface injury, this causes increased chance for platelet adhesion, aggregation, and followed by clot formation. The next point is the presence of natural anticoagulants, that is circulatory anticoagulants. They include heparin, antithrombin 3 and protein C. So heparin binds to antithrombin 3 and facilitates its action, and protein C inactivates the inhibitor of TPA or tissue plasminogen factor, and this increases the formation of plasmin. Also protein C inactivates the factors 5 and 8. The next point is the fibrinolytic system also contributes to the fact that circulating blood does not clot within the body. So that's about it. Thank you.